So today we will be solving a multi-step problem using two problem types, and we will also be solving this through using set models that represent the size of the set. So our problem is Justin has 135 footballs. 87 footballs are not flat and the rest need to be aired up. Justin lost a bag full of flat footballs. He has 29 flat footballs left. How many flat footballs were in the bag? So we're going to look at the first part of our problem. Justin has 135 footballs, 87 footballs are not flat, and the rest need to be aired up. So is there a change happening in the first part of our problem? No. So it's either going to be a part-part whole or compare. And it says that Justin has a whole of 135 footballs. So we know that this is going to be a part-part whole. So let's move on and introduce our first problem type, which is part-part whole. And so we have our whole here, and part A together with part B equals our whole. So our whole is the number of footballs. Part A is the footballs that are not flat. So the number of footballs not flat. In part B is what we are trying to find, and that is the number of footballs that are flat. Okay, so now looking at the second half of our problem, it says Justin lost a bag full of flat footballs. He has 29 flat footballs left. How many flat footballs were in the bag? So looking at the second half of our problem, did a change happen? Yes. He lost a bag full of footballs, so he lost some. So we are going to be, so our change is being a subtraction, so our problem type is going to be a separate. So looking at our separate, we have our start, our change, and our result. So our start is the number of objects that we start with, and then our change is what we are taking away. So when we take away our change, our start then equals our result. So let's talk about this equal sign real quick. Our equal sign, a common misconception that students have is that our equal sign means that a answer is coming up or it's time to calculate, when what it really means is that our equation is balanced. And so our start equals our result because it is a balanced equation. So now let's go ahead and label our start, change, and result. So our start is the number of flat footballs. Our change is the footballs that Justin lost. So the number of flat footballs lost. And then our result is the number of flat footballs that were left. So the number of flat footballs left. So now we need to figure out where we need to start solving our problem. So looking here at our start, it's the number of flat footballs he has total, but we don't know what that is yet. So let's go ahead and look at our part-part whole real quick. So we have our number of footballs and our number of footballs that aren't flat, and then our number of footballs that are flat. So we have our whole of 135. So our whole of 135, and then 87 footballs are not flat. So let's go ahead and put our part A, which are the number of footballs that aren't flat, which our problem told us is 87. So we have 1, 2, 3, 4, 5, 6, 7, and 8. And then 81, 82, 82, 83, 84, 85, 86, and 87. So we have our 87 footballs that are not flat. So using the tool of addition, we're going to count on to find how many footballs are flat. So we have 87, 97, 107, 117, 127, 127, 128, 129, 130, 131, 132, 133, 134, and 135, which is our whole. So we have 87 plus 40, 1, 2, 3, 4, 5, 6, 7, 8, plus 48 is our whole of 135 footballs. So the number of footballs that are flat is 48. So now let's go look at our separate problem type. So our start is the number of flat footballs, which we just found using our part whole, is 48. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So 48 footballs are flat. And we know from our problem that 29 flat footballs are left. So in our result, we need to put 29. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9. So we have 29 flat footballs that are left. So what we are looking for is our change. So to find our change, we're going to use the tool of subtraction because our equation here is not balanced. So we have 48 over here and 29 over here. So we are heavier on this side of our balance here. So we need to balance it out, and to do that, we're going to use the tool of subtraction. And so starting in our ones place, we have 9 over here and 1, 2, 3, 4, 5, 6, 7, 8. So I need to go ahead and regroup this long here into 10 units. One, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now I can subtract. So I need to subtract 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have subtracted from my ones place. So now moving to the tens place, I need to subtract 2 longs. Or I'm sorry, I need to subtract 1 long here because now I have my tens places are the same, so now they are balanced. And now my ones places are also balanced because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So now my start and my result are balanced. And this broken arrow here tells us that when we make that change, that this is no longer part of our balance because it's being taken away, because these are the number of footballs that he lost. And so the number of footballs that Justin lost is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So he lost 19 footballs. And so now that we see that, we have our 48 minus 29 equals our change, which is 19 footballs that Justin, or flat footballs that Justin lost.